10 seconds. Okay, good. Right, first thing, thank you for coming to this workshop. My name is Rémi, and today we're going to talk about ZK and identities, and more precisely about ZK and passport. So this workshop is going to be split in two parts. First, I am going to present you open passports, and in the second time, Michael and Théo are going to present you ZK Passport, which is another ZK Passport project. Sweet. So back 1 year ago, we realized that the identity market is really inefficient because it's actually not private nor secure. Right now, if you want to prove your identity online, most of the time you are going to go through the whole KYC process, which is actually not needed. And what's going to happen is you are going to take a picture of your ID documents and send it to the application, maybe do a proof of liveliness, so take a picture of you, maybe move the head a bit around to be sure that it's really you, and send it to the application too. And then you are going to pray. You are going to pray that this information is kept secure and that there will be no data leak. And spoiler, there is, and there is so many. Like a massive one just happened 2 weeks ago in France, for example. Also, it's not even secure from the point of view of the application, because a picture of an ID document or proof of liveliness is proofable so easily using generative AI, which is not good at all. And what's even more stupid is that when you do traditional KYC, you give all your information, which is most of the time not needed. You would like to give some kind of more granular information about yourself, such as proof that you are above a certain age or that you are part of a specific country, without revealing anything else. So what can we do? Fortunately for us, the International Civil Aviation Organization already built a nice tool on which we can piggyback on, which is the electronic passport. It's issued in 172 countries and carry on an electronic chip with inside a bunch of data about you, which is signed by the issuer country. So this logo is the one of the e-passports. If you got this one on yours, it's obviously an electronic one. And these are pretty cool because as the data is signed inside of it, that means that we can verify that inside the ZK proof. And by doing so, we can already target several issues related to identity. The first one is, of course, the Sybil resistance. How to prove that it's a human who's behind an action, a vote, a tweet, or anything else. The second one is the selective disclosure. I talked a bit about this one before. You may want to prove something really specific about yourself without revealing anything else. The last one is the compliance. As you can perform computation inside zero-knowledge circuits, you can actually prove that you are not part of a list of countries or that you are not part of the OFAC list without revealing anything else. So how can we do that, for example? So the OFAC list is the list of the people that US companies are forbidden to deal with, so mostly terrorists. And you can actually parse this OFAC list into a sparse Merkle tree, and then you can do a proof of non-inclusion of your name and surname inside this sparse Merkle tree. Sweet. Also, as you are going to verify a signature, ZK proof of passport are totally unforgeable, which is 1 point for crypto. You can't actually spoof crypto, that's not possible. Sweet. So now let's take a look at the passports. So in the passport, there is different data groups. For example, the DG1 is mostly the information that is contained in the main page of your passport. The DG2 is the image which is signed, which is pretty cool too, because we could imagine to do some kind of ZK machine learning tricks to do the proof of liveliness with the phone. That could be really cool. So these data groups are hashed, concatenated together, and hashed again. And the final result is signed by the issuer country. Or more precisely, it is signed by the document signing certificate, which is an intermediary certificate that can sign up to 100K passport. And this document signing certificate is signed by the country signing certificate authority, which rotates every 3 to 5 years upon the country. And those certificates are actually issued in public registries maintained by the International Civil Aviation Organization. So that's actually why it's so easy to verify passports, because we have access to the public keys. Okay, I kind of lied when I said that it was that easy because countries didn't agree on one signature algorithm and hash function. So this is all the primitives that are currently available in the passport signatures. There is even another country such as Germany that use 4 different ones, including ECDSA with SHA-1, which is quite kind of surprising. Yeah, okay, so if you want to see if open passports currently support your country, you can refer to this map. You can go to map.openpassport.app or scan this QR code. Basically, the countries in dark green are the ones that are currently supported. The one in green are the one issuing e-passports. We should support them soon. And yeah, if you pass the mouse on the country, okay, so that's a static screenshot, but if you go on the screen and you pass the mouse on your country, you will be able to see which kind of signature algorithm and hash function your country is currently using. Sweet. So my guess is that it's time for demo time. Like that, you will have a better idea of what we are doing. All right, so what's going to happen when you need to prove your identity using open passports is that you are going to scan a QR code. Scan this QR code. If you don't have the mobile application, it's gonna install it. And then the first step will be to scan your passport, or for demos like this one, you can actually generate a mock passport inside the application. So if you don't have the passport on you, that's fine, you can generate one. So let's do this because obviously I don't want to show my passport in front of everyone. So sweet, that's my new identity. Okay, so next step, when you onboarded the passport, you just have like to scan the QR code once again, and that's it. On the phone, there is written, Rainbow Chaser is requesting to prove you own a valid passport, which means that I'm going to generate a ZK proof and not disclose any information besides the fact that I own a valid passport. That's it. So let's do it. Let's generate the ZK proof. There is a WebSocket connection between the front end and the mobile application. For the technical side, we are using Grow16 and SciComm now. We are currently moving to Noir. And the proving time is around 8 seconds with SciComm. So sweet, the proof has been verified. All right, now let's say that you're an application that want to gatekeep the contents to users that are above a certain age. Let's see how you can actually do that technically using open passports. So you are going to use a really straightforward flow because we are in Web 2, we are off-chain, so it's going to be pretty easy. So what you're going to do is first obviously generate a proof of passport, and by that I mean verify the integrity of the data, verify the signature of the passports, and disclose the fact that you are older than 18 years old. And along with that, you are going to send the document signing certificate to the application. Like that, the application will be able to verify that these document signing certificates have been signed by one of the country signing certificate authority. So, technically, what you are going to do in the front end is import openpassport/core and instantiate openpassport verifier class. So what you just have to do is to declare a scope, which is basically just an app ID, and then the mode that you want to use. So in our case, we're off-chain, so let's use proof off-chain. Right, you will also need to set the minimum age to 18 and exclude countries like Germany for absolutely no reason. I'm sorry about that. Okay, so this is the information you can work with using Open Passport right now. We are going to add more of them. Right now you can deal with age, so gatekeep on age. You can use nationality, so gatekeep. So you can require user to be part of a specific country, require them to be not part of a country list, or ask them to disclose their nationality. And you can also ask them to generate a proof that they are not part of the OFAC list. Right, so once the first class instantiated, what you want to do is generating a QR code. And for that, you just have to import Open Passport QR code from Open Passport QR codes. That's a React component, and pass the Open Passport verifier that you just instantiated before inside this component. And that's it. The last thing you want to do is in the onSuccess callback function, you want to write some code to send the attestation to the backend to verify the proof in the backend too. Okay, so we saw that before. Right. So I told you that the connection between the phone and the computer is done using a WebSocket server. By default, you can use the one of Open Passport, but if you want to use your own, we actually provide you a WebSocket repository on GitHub. You just have like to clone it, and to start it, it's pretty easy. For the backend, it's also really easy. You just have to, one more time, instantiate the same Open Passport verifier class with the same scope and the same circuits, which is still proof of chain. And to verify the attestation, you just have to call Open Passport verifier.verify and verify the attestation. And that's it. Like that, you know if the proof is verified. Okay. Now, let's say that you have a DeFi application, so you want to use the same flow, but this time on-chain. It's going to be a little bit different because you can't actually send the document signing certificate to the DApp because a document signing certificate is too big to pass in the call data, right? So now you want to use ZK proof for the successness too. So what you're going to do is to send this document signing certificate to a remote prover. We actually need to do that because document signing certificates are most of the time RSA with 4,000 kbits length. So it's actually take too much time on client-side proving, but it's not disclosing any personal information. So you send this to a remote prover. It's going to send you back a DSC proof, and you are going to send to the DApp in the call data the passport proof and the DSC proof. So if you want to run, once again, there is a modal prover that we allow you to use, the Open Passport one. But if you want to run your own, you can. It's pretty easy. You just have like to fork the code and to run it. That's it. Right. So this time, what you want to do in the front end, it's pretty much the same actually. The only difference is you want to change off-chain for on-chain. And as we are in DeFi, we want to enable OFAC check because we don't want terrorists to use our application, and exclude some countries such as Iran. There is typing, so if you just type the I letter, it will propose you directly all the countries. Sweet. And for the QR code, it's pretty much the same. All right. Now. It's time for Nico to present you how you can verify this proof on-chain using our smart contract SDK. Okay.
Thank you. Hi, my name is Nico. I'm mostly working for a contract SDK at the Open Passport, and I will explain like how to integrate the Open Passport contract to your smart contract. So like the smart contract, you can do pretty much the same thing what you did on the off-chain. So like you can reveal, like you can generate a proof which reveals like a nationality, like an age, and then you can reveal it to the on-chain. So first, how to integrate our contract. So since the passport has like so many like signature algorithms, and we need to have like a different kind of verifiers for each algorithm. So like there is so firstly, like we generate like a verifier, the gross 16 verifiers for each signature algorithm, and then we will like manage in the generic verifier. And like generic verifier is kind of handle like what kind of proof is be like verified on like what kind of smart contract. And also like we also have a open passport verifier. Open passport verifier is basically doing like data formatting or something. So like this blue part is like handled by us, like it's managed by us. Like we're gonna update and we're gonna add more verifiers to it. And what you need to do is like just import open passport verifier to your smart contract. And how you do it is like this. So like firstly, like you need to import an interface of our open passport verifier. It's easy, you can install. It's already published as an NPM package. And like define your like open passport verifier instance. And like set your address on the constructor or whatever, like not only the constructor, but you can set our open passport verifier address to your smart contract. All right, and then like after you integrate our smart contract, I will explain how to call the smart contract. So like this is a graph. So like this on the right side, this is like an input. What you need to input to when you call the smart contract. And the left side is like the function name when you call the smart contract. And I will say at the first, I will explain the blue part. The currently like our open passport circuit is like we're gonna we verified all the DG1 like data. And we're gonna put like some kind of zero mask for like which we don't want to reveal the data. So like only the byte data which want to reveal is like coming it can be like a public value. And we also need to like format the like a byte data into like our readable data into like string or like into like uint. And then we need to do like those kind of like formatting, like our executions. And anyways, like your proof, like your hidden data is already hidden, so it's like 0 byte. But to reduce the gas cost on the on-chain, I recommend you to choose like what kind of data you want to reveal, and you choose you should set the selectors. Like what you attribute you want to reveal. So like firstly, you should define the like uint 256 array named selectors, and then like you just put like what you want to reveal. So like so those open passport attribute selector is already defined. It's also already defined in the library, and you will choose like what your data you want to reveal. And then also like there is also combined attribute selectors functions, and you call like this uint 256 array, and you generate combined selectors. So yeah, after you generate combined selectors, you can actually reveal the data from the passport. And then this is a red part. So after you get the combined selectors, you can call the open passport verifier dot verifier and verify and disclose attributes, and you can call the attestation and combine the selectors, and you will get like the passport attribute, and you will get like, for example, if you want to get a nationality, you can call was like open passport attributes dot nationality. All right, so
yes, thank you, Nico.
All right.
Now, let's take another example, voting. In this case, you want to target some maximum privacy preserving. Like you want to have the biggest anonymity sets and have actually no way of linking your nullifier with what action you are going to do and with the proof you want to send. So let me explain that. When you generate a proof of passports, you have to have a nullifier. And this nullifier has to be generated deterministically on your passport data. But for use cases that requires a really, really strong privacy, you need to hide this nullifier because maybe some countries actually keep the passport data, and it means that country could actually reforge that nullifier. So to avoid that, what you can actually do using Open Passports is to use a two-time flow. So first you are going to register to a commitment Merkle tree, and in the second time you are going to reuse these commitments, and this time do a proof of inclusion of your commitment in the commitment Merkle tree. And now you can disclose whatever data that you want, and there is actually no way of linking the final proof with your initial deterministic nullifier. So this flow is the same either you want to do it on-chain or off-chain. So as I said, the first step is send a passport proof. With only a commitment, you don't disclose anything and your initial nullifier. You want also to generate a DSC proof and to verify that inside a commitment Merkle tree. So this commitment Merkle tree can be either on-chain or off-chain. If you want to do it on-chain, for doing stuff such as a gated tornado cache, for example, that you could gate on the fact that people are not on the OFAC list, or just to be able to nullify people, you can just use the Open Passport smart contracts library, SDK. And there is this Open Passport Merkle tree reader repository that will allow you to listen the blockchain, listen all the events, and reconstruct the Merkle tree on an AWS instance, for example, or whatever. Sweet. And if you want to do this off-chain, this repository allows you still to run everything off-chain just with TypeScript code. So it can verify the proof, create a Merkle tree, store the value inside, and you will be able to call it to retrieve the whole tree. Sweet. So what we did also for Devcon is the cursive exhibition. And for that, we create a little game which is known as Steal the Flag. So this game is using Open Passport, of course, and it's pretty simple. What you want to do in this game is to steal the flag that is displayed on screen. Right now there is no flag because the game didn't start it, but if one of you scan this QR code and generate a proof of passport, he would be able to replace the background with its country flag. So let's do it. Okay, so now the application tells me that Open Passport, I'm not sharing my screen anymore, but what it's saying is basically just that Open Passport is requiring me to disclose the country of my passport, and that's it. So let's generate this proof. Once again, it's using WebSocket, so yeah, I think there is, okay, that's fine. And that's it. It's also playing your national anthem, and the counter is starting for the Bahamas. And by the end of the con, we will elect the winner of this small experiment. Sweet. So, thanks for your attention. That's the end of this presentation. Here is the QR code that links to the GitHub repository. You can also try by yourself the Open Passport Playground if you want to try the whole flow. As I said before, if you don't have your passport, that's not a big deal because you can generate one inside the application. So try it, give us your feedback because it's so valuable. And yeah, thank you for your time, and I would be happy to answer to your questions. Florent.
All right. Any questions? There's one here, yeah?
Oh, yes, please.
I can say you can repeat.
Yeah, I can also
Hi.
repeat it.
So why, if this is like open source and we have everything available, why aren't all the countries supported already?
Do you mean like why are not all the countries supported in Open Passport right now? Very good question. So there's a lot of different identity systems in different countries, and most of the time when it's a national ID, like an ID card, it only has one signature algorithm. But the thing is that passports are such a wide specification that is used by many different countries that can also have each of them their own security preferences. The specs are kind of vague actually, and so there's many different signature algorithms that many different countries use. So if you go on map.openpassport.app, you'll see a detailed map of all of the different countries, which ones are supported right now, and which signature algorithm each of them uses. So right now we support a lot of them, like most of Europe, the US for instance, because it's the most common signature algorithms. But there are some countries, okay, I won't name them, but maybe Austria, or maybe Germany, or maybe Iran. It's
I think we can name them.
Yeah.
Oh, maybe it's display on screen. Oh no, the screen is not showing anymore.
They require a bit more work because they have they used a lot of different signature algorithms, like RSA with multiple exponents. So it's just a bit more work. But I think in less than a few months, we can confidently say that we can basically support the whole world. All right, any questions?
Hello. I had two questions. The first being Open Passport, as I see on the website, is mostly proof of personhood, right? So we have other solutions working like World ID, who are working with the similar solutions like proof of personhood and civil resistance. So the first question would be, how is this a better solution than that? The second part being, so with Open Passport, we are generating ZK proofs of passport, basically the user. So in order to have this a global acceptance, we would need to have government involved in this or not, for the ZK proofs to be used everywhere, the ones that are generated using Open Passport.
So two very good questions. The first one is, how is that different from World ID? So World ID is what World is doing. I guess it was called WorldScan before, now it's World. So I think what the work that World is doing is also quite important because they're trying to tackle civil resistance at the biometric level. The trade-offs here with what we're doing is a bit different because World, there's a, if they can actually make the thing work and ship their hardware all over the world and everybody gets their iris scanned and everything, it could definitely be a very good system because then it does not rely on states. So we don't even have these trust assumptions of passports or ID cards. But it's quite hard to execute on. There's a lot of different attack vectors on the hardware, especially now with the new orb that can be managed by anybody, even without an operator. And they also have to ship it everywhere. It's not clear if everybody can have access to an orb. So we also chat a lot with them. We support a lot what they're doing. They're also supporting us. But I think the trade-offs here are a bit different. And with this kind of system, just like with what Anandar is working on, and we're planning on integrating Adar 2 in this, we can have we can support a lot more people a lot faster, basically, because people just need their phones. The other question, which was about do we need governments to collaborate with this? The really great part about this is that passports are already deployed, right? And the public keys are already public, unlike international registries. So we don't really need to ask countries, which is kind of great. There are some identity systems, not passports, but others, in which the public keys are not public, and so we need to actually ask the countries. So for instance, Nico worked on Mindable cards, which are the identity cards of Japan, and they need to ask for the government for an API key to check that the people's cards are actual cards. They don't have all the public keys available, but we have them. So we don't really need to, we can just bootstrap on what the government's already created. Of course, if we could have better communication with them, we could also have them have better standards, already have selective disclosure directly in passports, but it's very long processes, so we can go faster by doing this.
Okay, that sounds good. The other question that just came in my mind is like how will you handle like the fake passports that people generate? Like we have seen incidents where people have like 5 passports generated that are fake basically. Does Open Passport has something to handle that situations?
Good question. So what I really like about this is that today most of KYC works on just you send a photo of your passport. Okay, this is really bad. First, because of the data is stored, and so if it's leaked, like all of your private data gets leaked, and now people can like have phone numbers or like bank accounts with your data. But also, as you know, generative models like just got way better, and so now it's just possible to easily generate like huge databases of fake people and like KYC on websites. So this is why we like cryptography. Like maybe AI can generate fake images, but I'm not sure AI will like break the discrete logarithm problem for like RSA and the CDSA soon. So that's great. But if your question is more about actual physical fake passports, I think what's like my guess is that today most of the fake passports they look good from the outside, but they don't actually have a chip with a signature because this is really hard to get. You have to actually get the private keys from the countries and you have to get the right country, right? So it's like actually very like challenging. I would not be surprised if there were like some fake passports that had the whole signature thing and everything. I just think it's probably quite rare and that's kind of good for us, right? But in this case, yeah, if the whole passport is fake and the government kind of failed, yeah, of course, like you can do a proof there, but I guess that's like the trust assumption.
Testing? Okay. I had a follow-up question to your penultimate response about Japan's public key. So if the public key isn't public and only you have it, then if I'm doing a proof of my identity that I'm a Japan citizen, am I offloading that to you where you have the public key and you're not sharing it with me? Or do you share it with your users?
So good question. Nico would be able to maybe give more background, but my guess is that you have to call an API to check for a Japanese citizen. This is for the Japanese ID card system, not for the passports. For the passports, we can already do what we do. Okay. But for the Japanese ID card system, each time you want to verify, you have to go through an API by the Japanese government. So I guess there's like censorship here. But yeah, is that right?
Yes, if you want to like check the validity of that card, every time you need to check the like a government API, and like you need to like this is valid, this card is valid or not. Like still, the like RSA key inside the card is still available after if the card is revoked. So like it can be used as like a kind of wallet, like you can use the operation, wallet operation even after the card is revoked. But like for like, civil resistance, like for the eKYC, you need to call the government API. Yeah.
Thanks.
So there is also a question from the community. The first one is, can you ensure that Open Passport is not selling user information? Like which apps a user connected to?
Yeah, good question. So the nice thing about everything we're doing is that it's open source. Like the circuits are open source because it's the SDK part. The contracts are open source. They're gonna be on-chain anyway. The whole app is open source, and it's not even just like we open source stuff. It's like we're building in public. Like you can just see on the repo like us committing and doing everything. So you can like yeah, basically see everything that's happening. Again, like when you do an app on stores, there's always like, I mean, you never know if like the code on the GitHub is actually the one that's on the store. It's kind of a general problem with apps. I think that like Apple and Google Play Store are like every time doing kind of verifications, every time there's like an update. But yeah, I guess there's some trust assumption on the fact that the app is not completely compromised. If you don't want to do this trust assumption, you can just build the app yourself on your computer, load it on your phone, and then you know exactly what's running. And then maybe another question, in the case of pornography, on Spain, they want to implement some kind of verification based on the DNI, so I guess national identity system. So does this kind of solution solve this problem better? Our opinion is that yes, because the question is, if you're gonna go on an adult website and have to prove that you're above 18 or above 21, do you really want to send your like passport photo or something that's kind of sensitive? Maybe for banking it's sensitive, but in another way. I think for adult websites it's like more sensitive on like your personal life. Like if there's a if there's a leak, you don't want like people to have this data and like link it to you or something. So I think this is where it's very important, and also there's not really the compliance requirements that you have with banking, in which you have to check every transaction, do monitoring. For adult websites, it's probably okay, like I can prove that I'm above 18. That's why we're like super excited by use cases for Open Passport for this.
Another question is this Open Passport SDK made with ZK circuits, or what technology is behind it? So that's a good question. Open Passport SDK is mostly used to verify the proof. So it's not, there is no circuits inside of it, in a sense that it's just verifying the proof. So it's actually using ZK in the sense that it's gonna verify a ZK proof. But the generation of the proof is only made locally on the phone.
Are there plans to expand information to include financial data? Well, I would say that we like, you can already use Open Passport for like transactions. One thing that we're kind of excited about is what we recently prototyped, the OFAC non-inclusion proofs. So you can, for instance, prove that you're not on the OFAC list. And I think something that's exciting in finance for that is like, you can have a wallet that says every time you do a transaction, it's going to take the passport data that you already loaded inside your phone, and it's going to do a proof that you're not on the OFAC list live. And what is nice about that is that the OFAC list gets updated, right? And so you can do always a live proof every time you do a transaction. You wouldn't necessarily need to scan your passport every time, but you can do it once in a while to, like, we can enforce you to do it once in a while so that we can make sure you didn't like steal a passport or something. And then it could be, for instance, like enshrined in a layer 1 or layer 2, that's like all the transactions have to have this kind of compliance system. Or you could have a DeFi protocol in which you say, okay, like this function, when you call it, there's a modifier on the function, and I want you to like only include this function in a compliant transaction. So those are things we're excited about.
All right, can we scroll a bit on the questions? Yeah, perfect. When do you think it is necessary to do on-chain and off-chain validations? When is it better to use one instead of the other in a practical way? So that's a really good question. The first answer is going to depend on the privacy layer that you want. There is a really clean answer, which would be if the application is a Web2 application, just prove it off-chain, and if it's a dApp, then prove it on-chain. But let's say that you want a maximum of privacy, and you want to use the two-time flow that we talked about before. So first you are going to register and generate a commitment, and in the second time you want to reuse this commitment to then generate a ZKP. So in this way, maybe it's better to actually generate the first proof and verify it on-chain, because like that it could kind of centralize every users and have the biggest anonymity sets. Yeah, so another question.
Do you have an SDK to include it in native mobile applications? Okay, so there's kind of two answers. Right now, if you want to verify proofs in your mobile app, you can already integrate it, but people have to like download the Open Passport mobile app to like do their proof, and then you can verify it in your app. One thing we're like thinking a lot about is making a more general like package or SDK that you can add to do proofs and passport scanning on your own app. So for instance, you want a fully integrated flow. You don't want people to have to download the Open Passport mobile app because it's like some friction. You have to download a new app. And so you would just be able to integrate it directly in your app. And that would be also really nice. Another thing that we're working on is like app clips. So app clips is basically like something that iOS provides. it's like you can easily open like a small version of an app without having to go on the store and click on download and everything. And like we tried the flow, it's like very great. It's coming soon too, so yeah.
Okay, are there examples of some corrupt countries issuing signed e-passports? That's a really good question. I think the answer is quite all of them in a small amount, because most of the time for secret agency, they will need to like create a real passport. So that's part of the game. But they should not cheat that much. And there is probably some specific country, I won't name them, but it's pretty easy to guess which one of them, and that's why you can actually exclude this country when you want user to disclose their nationality.
Yeah, the kind of philosophy we have is that because all of the passport data is there when you scan the passports, as an app developer, you can have the flexibility to choose what you want. So if like one day one country's like certificates get compromised, you can just exclude this country or like this specific certificate, or like go more into the granularity, or like say, okay, this signature algorithm is not secure anymore, and like now people can forge proofs with SHA-1, let's say. So now like we can just exclude like people that have like this specific signature algorithm, or like find a better way to include them like in another way, or like if they renew their passports, like only support the newer ones. So yeah. All right. I think we're getting close to the end of our side. So we might just welcome ZK Passport to the stage. So ZK Passport is another team working on passport verification, bit of a different stack, different philosophy, and they can tell you more about their approach.
Thanks, Florent. Round of applause for the Open Passport team, everyone. Hi, I'm Michael Elliot. I'm a co-founder of ZK Passport, and this is Théo, Madzou, and we're going to go through, I guess some of you may already be familiar with what ZK Passport is, how it works, but today we're going to have a workshop on how to actually plug into it and to be able to leverage these identity proofs for your own projects or dApps. And so we've built out this SDK in TypeScript, which allows you to use this query builder. Yeah, go ahead. And with this query builder, as you can see up here, you can, like, as a high-level overview here of how it works, you just request, you specify which credentials it is that you're interested in, that you'd like the user to prove, and then the rest is sort of handled for you. You get this URL back, which can be displayed as a QR code. They'll scan that, it'll bring up the ZK Passport app on whether it's iOS or Android. And
So the idea is that you can try this out on your site. So I'm going to pull it out this as a QR code so you can scan it from your site. So if you want to join in, oh sorry, it went away. So you can scan this. It's a replit, a REPL, so you can try it out, fork it, try it out on REPL directly, or maybe try to do that locally. But the idea is that you can import our SDK.
Yes, please. Thank you. Just going to bring it full screen.
Oh.
So it's easy to see. Yeah.
Ah, okay. Well, thanks.
Should be a bit easier to see now.
I'm going to keep this out for a few seconds.
Yep, I think that's good to go. Yeah, so the idea here is that we have this replit that we made, so you're able to fork this replit and easily kind of get going by yourselves and test this in the browser.
Yeah. So I'm going to show it out how it looks like. So essentially...
Also, just a heads up, we don't have any fixture data yet, so you will need to use your own passports to be able to actually generate these proofs.
Yeah, you need to have your passport to test the flow. So you will generate a QR code with this example.
I was
where that
considering
SDK
lending mine to people that don't have it, but it may be a bit of a security issue. So
Yes, so you have to have your passport to do the entire flow, but I'm going to show it to you. So this is the deployed replit. So you click on generate new request. It generates the QR code with our SDK. You scan this with any QR code reader. So it pulls it out on my phone, and I'm going to, on this side, wait, if the Wi-Fi is good enough. Okay.
did you want to tether?
No, I think it's a more Wi-Fi issue because over the website.
No, tether through my cellular
Oh yeah. Yeah, go ahead.
to see if it shows up.
Well, actually,
Or you could do your own phone.
yeah. Okay. Let me try again. Oh, jeez. Do I have connection? All right. Now it works better. So, oh, sorry.
Yeah.
Oh, it disappeared. Why isn't?
There we
Oh, there it is. So the request was received. So this is like a little message that
go.
will be.
Use the camera. You can show you what's on your phone.
Oh, no, I don't want to.
Okay.
Yeah. So generating the proof, I generated the proof on my mobile phone, and now you get back my details, so first name, country, and that you can edit easily in the app by playing around with our different function, disclose function, greater than equal, if you want to make a comparison with the age, the birth date, or the data from the passport. So for example, I'm going to go here on the replit. So what we do here is like disclose nationality, disclose first name, but for example, we could add another disclose of like the, let's say, what should I disclose? Oh, what information? Oh, wait. Yeah, last name. Let's go with last name.
So for example, this might be a good proof for social media, where you just want to prove your first and last name, but nothing else. You're already sharing that information publicly anyway on maybe X, Meta, Twitter, and this could be like attached to the profile there, or maybe Warpcast, Farcaster. Could I maybe just get a show of hands of how many people have their own passports with them? Cool, so 5 or 6 people will be able to do this today. We should have maybe given that as a heads up with the passport. But at least you'll be able to see the flow and how it's achievable when you get home and you're able to use your actual passport then, so that's useful.
Yeah, so here I'm going to add another state variable so I can store my last name. I got air completion, that's pretty nice. So I'm going to complete, and here we go. So from the result, so the way the result is structured is I'm going to have the query result with the name of the field and whatever function you require disclose, or like if you do a comparison, it would be equal, greater than, or others, and then you would get the result. So in most cases that would be a Boolean if you do a comparison, but here you directly disclose the data. And you will get, you can actually log the proof. Like the proof would be right here, although I don't think I see the logs here. But anyway. And I can add, oh wait, field for the first to last name. So when I generate the request now, come on. All right. Did I do anything wrong? Jesus. No. Seems to have a trouble issue with the Wi-Fi. Oh, damn. Let me try to reload this. Has any one of you been able to pull out the replit? No? Do you want the QR code again by any chance? Do you want the QR code again? Oh, yes, okay. Yes. You can fork it. You can directly fork the page, and you can create a Replit account. Or I guess you could create like an Next.js, because like I just used an Next.js template. So you could create a Next.js boilerplate, like a simple app, and just integrate our SDK. I'm gonna also show a QR code towards the SDK repo, so you can get the link. Great, the connection is not good. I'm gonna switch back to the main Wi-Fi. So this is directly the QR code for the repo of the SDK. So it's not on NPM yet, so you can pull out directly the GitHub URL. Oh yeah. Can you just plug? Also, so we're available on both iOS and Android. However, currently the Android version is only available for internal testers because we kind of like released it too late. But if you're on Android and you wanted to join, please just this is my Telegram handle. Please just reach out to me now and send me your email address, and I can add you to the internal Google Play Store app so that you can get the Android version. Just one sec. Also, you can just message me. I'm ZK Mike. Okay, here's the QR code. So yeah, again, if you're on Android and you want to get access to the Android app, just message me your email address, and I'll add you to the Play Store app. I can give you my phone, just tap through it. I was using my phone, but that was actually worse. My cellular might be better though. It should be better. Yeah, it should work. To plug this in. If you're having issues still, let me know. You can use my phone to tether. My cellular is better. Okay, so now it works. After fixing those issues with Wi-Fi. So you got the QR code here, which is essentially embedding nationality first name and last name request. So in one more field compared to before. I'm going to scan it again with my app, ZK Passport app. Pulls out the request on my side. I'm being asked for my last name now. Just waiting for request received. Now I can accept. It's generating the proof. This is all done over WebSocket, end-to-end encrypted, using ECDH to set up the shared secret and ECDSA SEC P256K1 for the encryption. And you can see my last name in addition to my first name now. So this is, you can play around with the disclose function. You also have greater than equal functions, for example, for age, like if you want to prove that you're over 18. And in this case, it would essentially send out Boolean whether that is true or false, and that's the only information you're going to get back from the user. So I'm probably going to try to set up this. So let's say he's over 18. Actually, it's more 18 or plus. Okay. So now I'm also asked for my age, or at least an age comparison. I'm going to send it back. Oh, is it not showing? Oh, I forgot to. Wait. Oops. All right. Well, result. Was it? Oh wait, let me actually look back into SDK. Define my types. One details regarding this is that the whole SDK is strongly typed in TypeScript, so generally you will have like auto-completion that's pretty intuitive, so you know what to expect and what to put in. Yeah, that's okay. Yeah, it is. It's fine. What was I? I don't know. Like the edge I'm getting. I guess it's this.
So maybe now we can move on to also just describing the sub-circuit design we have and the reasoning behind why we've designed it this way. So on mobile, you're really constrained by the number of, by the amount of memory that you can actually use. And so we can't have our circuit size blow out too large, too big, or it won't work on mobile. And you want to have client-side proving on mobile because you want to keep the privacy. You want to keep your private, passport data local to your device. It's on our t-shirts. Own your identity. The meaning behind that is self-custodial identity, where you own your own data. And so, and also on that topic, after this workshop, there's plenty of t-shirts we have. So just, after we finish, please feel free to go over to the corner here and you can grab your t-shirt. We got a new batch in today because we ran out, so do you want to take it away there?
Yes, so regarding the circuit composition, wait, who in the crowd was in the talk yesterday we gave? Because I made a quick overview, but that was not very deep. I was hoping to go more into details, so actually now I'm going to do it. So yeah, you had that idea of certificate trust chain, which is similar to the SSL certificates, if you know how that works. So essentially, the passport data is signed by the state, but there's two certificates in the chain. There's an intermediate certificate, which is called the document signing certificate, the DSC, which is essentially signing directly the data. That DSC is directly in the chip of the passport, nearly all the time. There was exception. And then you have the root certificate, which is actually the source of trust. So the root of trust, which is like the certificate that signed the intermediate certificate. And that is a kind of certificate you can maybe get from the government websites or a registry provided by the ICAO, the International Civil Aviation Organization, which is the one that set out the standard and managed by the United Nations. Or sometime you may not find it and you have to find other ways to get it. So the idea is that within our circuits, within our zero-knowledge circuits, so in Noir, we do the verification of those two signatures, which allows us to prove that those data were signed by the state and then attest the validity and authenticity of the document. And the way we organize our circuit is that we divide it in sub-circuits. We don't want to have like a single big circuit, because otherwise we would have too many constraints, which would blow up the memory consumption. And memory consumption is very important on mobile, so we need to restrict it. So we have four main sub-circuits. One that will verify the signature of the root certificate over the intermediate certificate, which is on the left. One that will verify the signature over the passport data, which is the second one. And then one which will verify the integrity of the data. I will go back to that real quick. And then the final one, which is the disclosure. So if you want to disclose information, so like when you play with the SDK, this is essentially the one that's gonna disclose whatever you ask for. So like disclose field directly, or do a comparison of age, or any kind of like stuff you can build with the SDK. So we're trying to be very flexible here. So this approach has two advantages. So we split the circuit in smaller circuits that can be executed sequentially. It may take more time to generate the proof, but at least the RAM consumption will be not as much. So we can actually work without making the app crash. And the second one is it makes it quite modular, which is very important in the context of passport, because in this standard, there's a lot of flexibility in the kind of signature algorithm that can be used. So you need to have like a specific circuit that implements specific signature algorithm verification. So we have different circuits for all those kind of signature algorithm. We're going to add more. We support some of them. We're going to add more over the next few weeks and few months to support all the passports. And the idea is that you can just swap whichever signature algorithm circuit you need. So you are going to have one for RSA of different key size, one for ECDSA for different curves, so you can just swap it out. So it's very modular. So those are the two.
It also means we can add new circuits as new signature algorithms get added by governments.
So yeah, without changing too much. And Noir being like Noir coupled with Honk, and the backend bar Tabung being kind of proving scheme having a universal setup, we don't need to worry about generating a trusted setup every time. So managing new circuits and updating current ones is much easier than using Circom with Graph 16, for example.
Also, if anyone's trying this out with Replit and they're having issues, please just feel free to put your hand up and I can come over and try to help debug.
So more details on regarding the passport integrity check. So this is really core to kind of link the signature to the data that we use to generate the proof. Essentially, the data of the passport that we use is mostly derived from one data group. So they call those data groups. It's like the DG1, data group 1. And this is essentially the data of the MRZ, the machine readable zone. The two bottom lines you can see when you open your passport. Those kind of character with the little angular brackets. That's kind of like the filler characters. So those contain issuing country, country of nationality, birth date, expiry date, document number, gender, name, first name. So you have most of the information that you need from just this single data group. And this data group, among all the others, so there can be up to 16 data groups. Most of the time, there's only about 5 or 6 or 7. Only the two first one are mandatory. So the data group 1, we just talked about, the data group 2, which is the photo, like the one you see on the
It's like a
passport.
JPEG of your face, 20
Like a
kilobytes
full,
or so.
Yeah, like a full JPEG, like generally a couple dozen of kilobytes. And the rest of the other data group, you can have like the fingerprint, the iris. Those two data groups tend to be restricted, so we can't actually read them. We know they're there, but we can't read them. The state need to authorize you specifically to be able to.
This is where like countries would give access to other countries they trust.
Yeah.
Otherwise, you'd be going to airports around the world and they'd just be scanning everything, which is not ideal.
You got a couple of free-form data groups as well, and some other data group, including like an interesting one, the 15, data group 15. That means that when you have this data group, a passport can actually sign stuff. Not all countries support this one, so it's unfortunate. That would be an interesting primitive to have.
It's quite powerful, actually. It essentially makes these passports into a type of hardware wallet, allowing you to sign over data.
Now, for example, my passport doesn't have this data group. It uses another kind of like, it does have a private key inside, but that private key cannot sign deterministic messages, like challenges. It's only like deterministic stuff. Because some countries don't like the idea of being able to sign whatever you want with your passport.
It may give too much power to the citizens, perhaps. Who knows?
So yeah, so that's unfortunate. So all those data groups, all the data of those data groups are hashed using a different kind of signature algorithm per country. Again, that's up to them, but generally it's going to be SHA-256, SHA-384, or SHA-512, like different variant of SHA-2.
Something else is quite interesting. This is all encoded in what's called LDS on the passport, logical data structure, and so that's the current version that's used around the world. But there's also a V2 coming out at some point, LDS2, and so LDS1 supports the ability to read data, but LDS2 supports the ability to write data as well. So you can imagine governments maybe using this, so when you travel around, instead of getting like a physical stamp on your passport with the ink, you'd actually get like a digital stamp that you've traveled somewhere. So that could be cool, and then you'd be able to generate zero-knowledge proofs from that data that a government has attested to the fact that you travelled through their airport, and that could be a cool use case for that. Or a privacy nightmare, depending how you look at it, I suppose.
So all those hashes then group together and hash into a final hash, which is what is actually signed. There's some padding adding to this, but the overall idea is there. So the final hash of all those hashes is signed, and this is what we call the signed attributes. So the content is the gathering of all those hashes, and then the final hash is the signed attributes. And so from those signed attributes, this is, since if you verify the signature over that message, and what we do in our circuits is that we go from the DG1, get all the other hashes that are provided, we group them, we do the whole process, kind of. We verify that indeed the data, after being hashed from DG1, gives back the same message that's being signed, so that way we show that the data we're using is the data that was signed. So that's the data integrity check done here.
And then finally, there's the disclose subcircuit, and this is where you're actually able to generate proofs to reveal selectively information, mostly from DG1, because that's where all the interesting information lives. And so you can just do a simple, so when you're actually specifying what it is that you want to disclose, whether it's the first name, last name, this country, this kind of stuff. Gender is even possible. You create like a byte mask, and that byte mask combined with an actual output DG1, like the reveal DG1, in the circuit, it will reveal wherever there's a 1 bit, or 1 bit, sorry, just like a 0xFF. And so all the characters, the 93 characters of the DG1, you're revealing selectively information in that way. And then there's also other possible circuits that are a bit more dynamic, like proving that you're over a certain age. So essentially you'd have, as a public input, you'd have the age that you're trying to prove that you're over, and you'd also have the current date as a public input. And then it would, in the circuit, it would be responsible for extracting out the date of birth that's in the DG1, and then doing like a delta check between the current date, that's a public input, and your date of birth, and that must be over the input age, the public age input. And that's the only way you could generate a valid proof for proof over a certain age. And so we can also create new circuits in the future because of this modular design to allow for disclosure.
Yeah, and so the way we kind of make the circuit link to each other, because if you execute them separately without any glue, it doesn't mean too much, because you can easily cheat, like with the data you put in.
You can easily cheat, which is why you need commitment.
So you have like commitment between each circuit. So like the first circuit on the left, which verify the signature of the intermediate certificate, commits to the public key of the intermediate certificate. That commitment is checked into the second circuit that it is indeed, you have the public key of the DSC including that commitment that was generated by the other circuit.
And by commitment, you can just imagine that as like a hash over the data that you're trying to pass to the next circuit, but then also you obscure the values of the hash, called a pre-image, by using this secret so that no one can like figure out what it was that was being passed between circuits.
Yep. And so you have a commitment that's linking the two others from the second and the third, essentially over the signed attributes. So that way you know that that message that was verified against, the signature the message was verified against, is indeed the same you checking the data integrity checked against. So you're sure that that data integrity checks does match with the signature. And then the final glue is like with the DG1, so like the data group you derive the data from, so you want to make sure that the data integrity check is done over the same DG1 that you're going to disclose. So all this together makes it so that they all link together. You cannot cheat. The prover cannot cheat trying to prove wrong data.
Because they're all in committed sub-circuit relationships.
Yeah. And then we also have this idea of the nullifier. So from some of the data from the passport, we derive a private nullifier. Well, it's called like secret.
Yes, we're calling it a secret nullifier here, but private nullifier is also possible. And the reason maybe we could change this to private is because the government probably knows the data on that passport. So while it's private and not something you're sharing around publicly, there is an entity that may know. So we call it the private nullifier.
Yeah. And so that information is also added with a salt, a private salt that's generated by the user on his mobile phone. So that allows to add some randomness to it.
And allows for full privacy, so even the government knows the passport data, they can no longer deterministically find the actual nullifier because you've obscured it with this salt, and that's important.
And the actual final nullifier that's revealed to the service is scoped to the domain name of the service, plus another subscope that allows the service, so essentially the service is like the developer that's asking a request of data from the passport of the user. It allows it to essentially restrict a specific use case. You could have like a subscope named voting, a subscope named proof of personhood, whatever you need to do.
It could be a poll, specific poll, like poll ID 420. And then for the actual service scope itself, we use the domain name. So that's the same domain name that must match on the website you're at. And so in the QR code, that's also encoded, which is why the request comes up so quickly. But the client-side app is actually also checking that that is indeed the correct domain name. So you can't just spoof some other service's domain name, which is also quite important.
Yeah, so and essentially that pretty much wrapped it up.
Just to clarify, the reason for the service scope and why this is important, if you just use the same nullifier that was global, it'd be easier obviously, but it means that if I were to use service A over here and I were to vote in some kind of poll, that would be a nullifier that would be used to ensure I don't double vote. and then if I were to go to service B over here and vote there, they could easily compare, or maybe it's public even, and see that I actually am the same person that use these two different services. So the service scope allows for privacy between different services. And then again, the subscope, even more privacy that's more granular. Should we open up some questions?
Yeah, I guess I can open up some question. Did anyone? Oh, wait. It didn't. Well, never mind.
Hey, I'm gonna jump the queue.
Okay.
So all the circuit stuff is really cool, and that's like the theoretical stuff that makes it possible. But productionalizing it is what I think is like happening now that hasn't been happening like before now. So I'm interested about actually the toolkit for Honk and like the client, the either mobile or desktop side proving that like is performant. What are the tools that you're using for that?
For Honk proving on mobile?
Sure.
Yeah,
whatever you're proving.
Yeah, so originally like Bartenberg didn't work well on mobile, so we worked on some mobile tooling for generating the proof using Honk on mobile. So like essentially the way it works is that we have bindings to the Bartenberg C++ code base, so the C backend used by Honk, in Rust. And those bindings, we use them into a library that allows us to generate the proof for any kind of targets. Actually, it works on macOS as well, but then we optimize it for iOS and Android. And that Rust code, we bridge it to Swift and Kotlin on iOS and Android respectively, which our own app is in React Native. We then link that to the JavaScript code. So that's a lot of bridging all the way from C++ to JavaScript.
And the iOS library is called SWA, that we built out to use this on mobile. And so it's a portmanteau of Swift and Noir, SWA.
Yeah, the other one is called Noir Android or Noir Droid. Still deciding on the name. I'm not sure which one is better. Maybe you have an opinion, not sure. But that's the general idea.
Awesome, thank you.
So we get some question here.
Regarding the age one, I saw about a government using a particular type of age verification. I think this is, just generally speaking, this works really well for age gating adult websites or gambling websites, because essentially you've got a government somewhere attesting to this information about the citizens of the country, and then you can use zero knowledge proofs, so whether it's an e-passport or some other system, you can use zero knowledge proofs here with our system to just prove that you're over 18 and reveal nothing else. So whether it's their system that they use or this, I think it's a wonderful solution. Like, I can't think of a better solution than that.
So I believe the two bottom question are ours, right? The two bottom ones? What was it like? Oh, no. Okay, there's more than I imagined. Okay. Which one? There was a question about the difference between Open Passport and ZK Passport. I'm going to cover this real quick. I think this has been asked in a panel as well, where Michael and Florent were speaking. So yeah, our projects are quite similar. We cover like a similar idea. So they use Circom originally for their circuits. They are mostly supported by PSE from the Ethereum Foundation. We kind of used Noir from the get-go. We did use Circom at some point to get things working, especially for the Devcon integration. At the time, Noir was not stable enough for us. But now it is, so we are fully using Noir, like completely 100%, no more Circom, no more Groth 16 whatsoever, no more Z-key. So the difference is we tend to put a lot of focus on, I would say, UI and UX, and also a bit of DevX, because we want to have like a good SDK and everything. So like right now what you saw is a TypeScript SDK, strongly typed, but what's coming up in the next few weeks or few months, it will be a React SDK. So the idea of that is that you have a single component, you plug it in, no API key, you set what you want from the passport, and that will be all. We'll take care of all the rest, the QR code generation, the progress with all the UI updates, and a callback with the results. So we really put a lot of focus on that.
Yeah, and I think we're also discussing with them something that makes the most sense to duplicate effort is to actually merge the two projects together.
It does make sense because they want to switch to Noir as well. So you're going to have two projects working on with the same stack, same proving scheme, same language. So it makes more sense to merge. That's something we're working on.
There's a question about how can you ensure it's not like forged. you'd have to actually break like RSA encryption for that to be the case. So you can be you can have the assurance that it's genuine, unforged passport proof because of the cryptography involved. Oh, and that's a great question, yeah, about the last one here. Is there anything done to address the I borrowed my friend's passport issue? So the way that we can solve this, we'll be doing this quite soon actually as a feature we're going to build out, is you can generate a face fingerprint from the photo, the JPEG on the passport that's also been attested to by the government, so you can trust it, and then we'll have the users with their iPhone, they'll scan their face, all local, nothing leaves the device. You scan your face, it'll derive a face fingerprint from that that's going to be, you have the guarantee of the TE on the iPhone, so it's a trusted execution environment, and we can use the app attest service to ensure that. So in other words, you know it's our code running that derived the face fingerprint and not like a jailbroken iPhone. And then you can compare those two face fingerprints in zero knowledge to prove that you are the same person that's scanning the passport that is also on the passport, which I think is just magic. That's pretty cool to be able to do that to a service, like provide that to a service. Yeah, I did already, yeah.
Okay. So we got a question. How will this affect KYC requirements if none of your personal information is passed on to the service provider? Yes, so this is often a requirement for AML and CTF in many countries, that you should be able to give out the information in case of a suspicion of fraud and like or money laundering or terrorism financing. So yes, it might be a bit of an issue for full KYC if you have like full self-custodial identity. But I believe that with blockchain, where we have like more of a gray area, we have an opportunity to nudge into a different direction. So, and actually that's probably where we're heading with Obsidian, the wallet we're building on Aztec. So Aztec is a privacy preserving layer 2 for Ethereum. So using Noir as the smart contract language. And the idea of Obsidian is that, so it's going to be one of the first wallets on Aztec, and it's going to integrate natively ZK Passport. So you're going to have privacy, compliance, and identity at the wallet level natively. So essentially, we're going to be able to provide to dApps an easy way to request proof of identity and compliance proofs. And it's going to be very smooth for the user. It's not even going to realize it. It's going to be self-custodial. Now, we've been kind of entertaining the idea with Circle of like a compliant USDC on Aztec using Obsidian. So every time you would make a transaction, you would have a check that would be done. That would include, for example, a local check against OFAC list, another SDN list. So that can cover its a moderate risk, not high risk, I would say. So this is like a way toward compliance on-chain and compliance with using self-custodial method instead of having to store the data. Now, yeah, you're not going to be able to use ZK Passport for full KYC in the traditional world, but if we nudge in that direction, maybe the minds of regulators can change if they can see applications into this space.
Yeah, and the reason this works really well for a private stablecoin like USDC on Aztec network is because every time you transfer that USDC around, you're generating proofs again. So you're actually checking against the current OFAC SDN list and sanctioned country list. So instead of, it's kind of inverted a little bit. So instead of you giving that to some provider that's checking themselves every day, you yourself are checking just by the fact that you're generating a proof, but all privately. And there's some other cool checks there as well. You could have like you provide like this super generous limit of say 100,000 USDC per month that is enough for like 99.99% of people, but it's going to really mitigate and prevent a lot of bad actors from using this with like hacked funds, that kind of stuff. And that's going to be using the nullifier that you saw before. And that's going to allow you to transfer privately USDC and then off-ramp if you wanted to like a, to Coinbase, Binance, wherever, and not have to worry about getting your account banned because it's like a privacy coin.
I think that's it. That's it.
Any other questions that we haven't covered that maybe somebody wants answered? Just feel free to raise your hand and we can. Yeah.
Where can I find the diagram? The slides?
Oh, the slides? We can share them with you if you like. If you just message me on Telegram, I can send you them through. Cool. ZK Mike. something in the slides that we didn't quite get to? The sub-circuits?
I think the sub-circuit was we pretty much covered everything on it. And where's the slides?
We'd also love to hear about any ideas that anyone has. Oh, we've got some questions popping up. Great.
Hey. So there was that question about the KYC requirements. Are you guys aware of any governments that are moving towards accepting a ZK proof of a passport as essentially the same thing as having provided your passport?
Yeah, great question. I think a lot of this is really sort of uncharted territory. And so we have the opportunity to get in front of FinCEN and speak with them. I think that's really a matter of just having those conversations with regulators and showing them, explaining how the tech works. It may take a lot of time and effort, but I think once this new paradigm of zero-knowledge proofs and how it can really unlock these new features, and they can see that it's actually working, I think that'll really help to warm the government to these kind of new approaches. And there's also ways that this can work off-chain, but provide way more security than just a photograph of your passport. And that whole model, I think, would be completely broken. It already is broken, but it's going to become more broken with the generative AI, these kind of things, due to the fact that it's unforgeable. And these proofs are one-time use as well, so you can't replay them easily. And so, in the example of needing the data to check it maybe every day against your OFAC SDN list for banks and some financial institutions that need that kind of security, you could simply just have it like off-chain. So you can generate a proof that reveals your full name, date of birth, and country, and maybe a passport number if you wanted to. And you might ask, oh, but that's already available, if you send a photograph in. Yeah, but it's a photograph of your passport. If it's a proof, it's unforgeable. So they can take that, they can have it on their server, it's never revealed publicly, and they can do their daily checks against the OFAC SDN sanctions lists, and they have a far increased, ability to be sure that it's actually authentic. And I think, it's just going to take time for governments to start realizing that this tech, it's still very new tech, it's just like bleeding edge to kind of warm up to this. Thanks. And I think if anyone has any great ideas about use cases or wants any help, please reach out to us on Telegram, ZK Mike, or even just Twitter. Please just tweet out to us, ZK Passport, and we'd love to reply and brainstorm some new ideas with you guys. If you have anything you're building, also please tweet that out to us, and we'll help to promote it and share it, and also work with you guys to build out cool use cases. And ultimately, what we're building here is public goods, open source, reputable identity infrastructure for Web3. And so we want as many projects to build on this and be able to unlock these identity primitives to make use of them in really cool, interesting, and novel ways. And so I think that pretty much sums up our workshop for today. So thanks everybody for coming. This has been really fun. I really appreciate it. And if you guys would like some t-shirts, we have the last batch available in the corner here. So please help yourself.